This is a presentation on data displays and picking the right display for the data you have. So let's do a quick review on data types. Categorical data, if you remember, is like for a car, red, the model, the the color. It's the category. A lot of things fall into categorical data, even certain numbers, because you can't really take the average of certain numbers. Like for example, the zip code we talked about was not really quantitative data; it was a categorical data because you can't really take the average zip codes, right? You would use other things like you would find the mode, the one that shows up the most, to find the most popular zip code. So when we think of categorical, we think of things that are not numbers but more categories, right? Quantitative data involves numbers. We have continuous data, which means decimals, versus discrete, which means whole numbers. And for example, the number of accidents that happen. So the number of So the number of accidents that happen based on the color of the car, right? So the number of accidents, that's quantitative data, right? Categorical data would be the color of the car, right? So now we're going to talk about displays. The first display that we're going to talk about and use a lot is the histogram. A histogram will take one column of quantitative data, and what it does is it shows the distribution of that data. So for example, here we have the heights of black cherry trees, and we see that, most of the heights fall between 70 and 80, right? So, we can say that it's distributed mainly around 70 and 80. It's continuous data, meaning that decimals are okay. And the reason why is because we use these bins to hold all the numbers in between. Here it's every 5. So all the numbers between 60 and 65 can go in here, including 60.112135.6, right? Which would be a continuous number. So all these numbers would fit into these bins. From your animal data set, a histogram would be perfect for the weights, right? Because the weights are decimals. A bar chart, bar charts and histograms, they compete with each other. Sometimes it doesn't matter which one you use. A bar chart, just like a histogram, can take one column of quantitative data, but it can also take two, actually. So, for example, here we're looking at the hearing loss between people in their 70s versus people 80 to 100. And so we're comparing two different data sets, right? All numbers, right? The percentage of 70-year-olds that lose their hearing uh, versus the percentage of 80 to 100-year-olds that lose their hearing versus how many can't lose. Compare things between two groups or track changes over time. Discrete numbers, we use it for here, right? So we would use, notice how it says 1746, right? That's the number of people in the study, 70 and 90, right? That kind of that fall into this. And then the animal data sets would be weeks and age, right? Because in our animal data set, weeks it's whole numbers, and same thing with age. You could also do dog versus cat, and seeing how long it takes, the cats versus dog to get adopted. Box plot is also something that we're going to look into more deeply, but you just need to know that it takes one. It's very much like the histogram, where we're using it to look at distribution. It's just we're using it to look at quartiles, and we're using it to find the outliers faster. All things that we'll go into more detail. The thing you have to just remember is that when we have one column of quantitative data, we can use a box plot. And for example, we can use a box plot for weeks, age, and the weight. A pie chart, it's a one column of categorical data. We use it to find percentages. And so, for example, in the animal data set, species would be very good, right? We could see the percentage of cats and dogs, and I think there's a snail in there. So a tarantula. So we can use it for species. We can also use it for fixed, right? How many animals are fixed versus unfixed, and that is categorical. A scatter plot, it's used for the two column of quantitative data, and we can use it to find a correlation. Is there a relationship between X and Y? Is there, as you increase X, will Y be increasing or decreasing or not at all? And so, for example, we can use the scatter plot to see if there's a relationship between age versus weeks, or the weight versus weeks, or the number of legs versus weeks, right? We could take two quantities, two numbers, and start plotting them to see if there's a relationship. All right, that's it for the lesson. Now just fill out the worksheet and then complete the coding assignment, and you are done.